Welcome back to the channel. Thanks for tuning in again. Today, 447, we're still not finished measuring things. Need to measure the pistons and find the diameter. Need to measure the bores and find out how much piston to wall clearance we have. And then we need to check on this base gasket. There's some holes in here on this one that are very significant. So let's get started and measure these up. Now, I've said before that the information for this engine is a little lacking, and I think it was when it was brand new. So how do I find the diameter of this piston? With this one, I'm just going to, it's probably going to be around here somewhere where I need to measure. There's a dimension for 503s and 582s where you measure from the bottom of the skirt to a certain point, you make a mark on it, and that's where you're to measure it. Because that's not stated on this, I'm just going to measure this and find the biggest diameter on it. So this is where I'm starting. So I'm kind of closer to the skirt at this point. Measure through. It's getting bigger as I go. Smaller there. Smaller there. So somewhere around the middle here. Okay, so what I'm going to do is, sorry, it's a little tedious to get this, so it's right. Okay. Okay, it has a good feel when I slide it back and forth, and of course, this is clean. I haven't cleaned the whole piston yet because I don't know if it's any good, and I've already wiped the points here. So what do I have? I have, let's get ready to mark this down, mark this on the piston, and I have, of course, 2 inches. It was around about there. I took the measurement, 2 inches, 654, and there's a few tenths. I would say maybe it's about 6 tenths, 5 tenths. So I'm looking for the line on this side that is the same, which is this line and that line, which is 6. So we're going to call this 2 inches, 654, 6. In the description for this, they just want you to go in thousandths anyway. So that's fine. So that's that piston. This is the PTO piston, so that's that cylinder. And let's move along. And I'll just make a mark on this one right about there. And that perhaps will be the biggest spot with the greatest diameter on this one as well. Let's find out. 54 is getting bigger. Okay, I'm gonna call this one right there. Okay, and I have a nice fit when I slide the piston through. And on this one, we have 2 inches, of course, 650, and then we count up here 1, 2, 3, 4, and it's right on the line on the back side. So it's 654, and that's in inches. So the clearance stated for this is 3.5 thousandths, so 3.5 thousandths piston to cylinder wall clearance. That would be new. Of course, this is not new anymore, so I'll expect it to be a little bit looser. And I apologize for the screaming, screeching noise in the background. I have the shop doors open today, and the auto repair shop across the street is torturing a drill bit over there and making that noise. Okay, now getting back to what we're doing here. So we have our pistons are both measured now. So we want to find out what the clearance is. They don't actually give us a specification across for the diameter of the cylinder. So we're kind of going to work, I don't know, I'd call it maybe a little bit backwards here, but I'm going to start from, this is the last one I did, and it was 2 inches, 654 thou. So I'm going to zero my bore gauge at 2 inches, 654, and then we're going to find out how much clearance we have. It'll read directly. So that's what we're going to do now. So just let me move the camera and we'll get this set up. So here's my cylinder bore gauge, and I have it set still where it was at 2 inches, 654. And I'm going to put it in between, and I center it in between the points, and I'm looking as I go to get the highest reading to be 0. So a little bit of patience is required to do this, and I'm happy with that. So now let's move that out of the way. That was the mag cylinder that was for the 654. Okay, so there's a process in here where you need to take it over in this direction and then 90 degrees top to bottom. I'm just going to show you this this part so you get an understanding of what it is. So it goes in sideways, and when you stand it up, you'll notice, I guess you won't if the camera's not high enough. Okay, so when we insert it in and stand it up, you'll see the dial turn, and I've relabeled this one. So this is the +1, +2, +3. This is actually +4. So it's about 4.5, I'm going to call that. And this one is in tenths. So that would be the same 1, 2, 3, and then we'll be 4.5 on the plus side. So in other words, bigger. So the clearance then is 4.5 thou. And I'll finish up and I'll go and check the rest of it so I can record it, but I'm pretty happy with that. So let's go over and check the PTO one. Now remember, the PTO piston is 6/10 bigger than in diameter than the mag cylinder. So let's see what we get. I'm going to leave this set the same way because they really said in the old publication just work in thousandths and don't worry about the tenths. And this is, well, look at this. So there's 1, 2, 3, 6 is 4.5, and 4.5, 90 degrees to that. So that gives me, I'll call this plus 0.045, and I'm going to do this one the same way. So this one is absolutely is 6/10. Whoops, 6/10 tighter. So there's our piston for the mag, and there is the clearance to the cylinder. And we were looking, the new spec was 0.003.5. So there's so how much wear is in here? About 1,000 since it was new. So I would say, what is that going to equal? Okay, low hours. All right. Okay, now the other thing I want to talk about, so I'm satisfied now. I'm going to clean the cylinders all up, make them all look like new, take the rings off the pistons, of course, clean the grooves. That one sort of clean just from wiping it, clean it off, clean these up so they look like perfectly new, and get all the gunge out of the inside of them because they have, well, this one has less. Now I'm going to expand upon this a little bit. So we've already done our measurements here, and we determined that there was 1,000ths of wear. Okay, and we know it's low hours, and it's all good news, but that's great. Where did the 1,000ths, where is it worn from? Is it all worn from the skirt on the piston? Is it worn because now the bore is bigger, or is it some combo of the two? So how we can find this out, which is kind of interesting, is on the top of the piston, you can see right there it says 67.45. That's in millimeters. Okay, so we're going to go 67.45 millimeters. Now I want to convert it to inches because I like inches. So I'm going to divide it by 25.4, which is a constant for going back and forth in between inches and metric. And this is going to equal, so the answer is going to equal our new piston diameter. Okay, now let's get out the trusty calculator with the tech, and we're going to divide it by 25.4 equals. So we're at 2 inches, 655 in inches. So when this piston was brand new in metric, it was 67.45 millimeters, or in inches, it was 2 inches, 655.5 thou. So that's where it's marked right on there. Aircraft pistons are bang on. I've never ever seen one there's any tolerance on. It's really quite amazing. Now, where are we at now? So let's look and find out. So we know, let's see where the wear came from. So we had the piston when it was brand new, it was 2 inches, 655.5 inches. That was new. And the actual is, what was it? It was 2 inches, 6, 5, what was this one? 546. Yeah, 546. 546. So what's the difference in between what our new dimension was and what our actual dimension is? So let's do a little bit of math here. This is going to be 9, and that'll be 0, 0, 0 point, and of course that's a 0. So this is in inches. So 9/10. So we have 9/10 wear on the piston. But if we want to get really critical and go into the other tenth, to get that extra from 3.5 thou clearance to 4.5 thousand clearance, that means that this is piston. Then the bore would be wear on the bore of the other part, which would be 0.001 of an inch. So I don't know if that all makes sense, but that's the way you can do it when you convert over to metric to inches. So metric piston diameter brand new divided by the constant gives us our brand new inches diameter. Okay, so here's our inches diameter on our brand new piston. Here's our actual diameter that we measured. And the difference is 9/10 of a thou. So there's 9/10 wear on the piston. And where's the other part of the 1 thou? Well, that's 1/10, and it's right here. So we're in the bore. So that's how I calculate these out. Now I'm going to get a fresh page and we're going to do something else. So we know for sure when this was new that it had a piston in it was 2,655 inches, because that's what the piston told us it was. Then we're going to add on, what was our piston to wall clearance? Well, it's 3.5 thou, so 0.035. Okay, so let's do the math on this. So this is the piston. This is the clearance. Whoops. And this is the bore size. So this will be the bore size that I expect to find. So we'll just do the addition here. So we have 0 and we carry the 1 and we end up with 9. and 6, 5, and 2. So our bore, well, that's pretty messy, should be 2 inches, 6, 5, 9, 0 inches is what the bore should be. Now, what I'm expecting is that it actually is, if you go by the math that we just did, is that because it has a tenth of wear on it, so this would be 2 inches, 6, 5, 91, if you want to be really super accurate with it. Okay, so that's the way we can calculate, or I can calculate back and forth as to what I would expect the bore size to be and how I determine where the wear is. So hopefully that all made sense to you. A tenth off of the bore is really negligible. So if you just wanted to round the piston and do it that way and say, well, there's a thou wear off the piston, then that's fine too. Okay, either way, what I said is it equals low hours. Okay, so we'll move along, and I want to talk to you about that gasket. So of real importance on any of these engines is the thickness of the base gasket. It has to do with the port timing. And this one I measure, as I always do, this one is 20 thousandths thick. That's fine. But because this one actually had these holes in it, I thought I'd mention this because it's kind of cool, because you really don't see this at all anymore. These holes, there's a piece missing out of the top here, so it actually is 4 round holes. There could be 5, 6, up to 8 in there, depending upon the thickness of it. And each one of these represents in inches 5 thou. So this tells me right off the bat, so 5, 10, 15, 20, that it's 0.020 inches thick. So I must really make sure that the gasket that I put back into this is 20 thou thick. I know that this engine is supposed to have a 20 thou thick gasket, but I need to ensure, because things are not like they used to. So I got to make sure that it's 20 thou thick, or it's going to affect the port timing, moves the cylinder up or down, which affects the compression ratio. So it could end up with a lower compression ratio. So the compression ratio could be lower if it's much too thick. So and if it is way thin, so say it's 10 thou instead of 20 thou, the compression ratio is going to go up. We could have detonation, pinging, engine damage, all kinds of things, and we don't want that. So anyway, just thought I'd mention that because you just don't see this anymore. This is kind of cool with the holes in it. So they were easily identifiable. You know, I want one that's 20 thou thick. Okay, it needs to have 4 holes in it. It was a very simple system. No holes now, you got to measure it every time, but you should be measuring it anyway. Well, thanks for spending time with me today on part number 4 of the Rotax 447. When the gaskets come in that are on order, I'll have all the parts cleaned up and we'll start to put it back together. That'll be part number 5. Stay tuned. See ya. Bye.